Well there, boys and girls, we're back at the lathe. Manual focus, probably not a good idea. We are going to look further into the issue of the headstock, tailstock and bed. Well, not necessarily the tailstock. For the moment, I know the tailstock's rough. I know I've got work to do on it. I have blued up the bed and it doesn't seem too bad, or at least blued it up and run it on up to about here, which is where most of the work goes on, I suppose, which is probably not such a smart idea. I should probably blue up the whole thing, but that means getting my big marble surface plate out of there. It also means totally taking everything off the lathe, bluing everything. Yeah, it's a pain in the hole, so it can wait for the moment. What we are going to do is look at the alignment of the headstock, which we cleaned and reclamped yesterday, day before. The alignment of that to the bed in the Z, not in the Z axis, in the X and Y axes. So on a lathe, this axis here, running lengthways, is the Z axis. This axis coming in and out is the X axis, and this axis is the Y axis. It is very important for the spindle, the centre of rotation of the spindle, to be absolutely parallel with the bed in the X and Y axes. Because otherwise, if you move your carriage along the Z axis, you will be turning a taper. It's obvious to see why in the X-axis, because if your carriage is moving away like this, you will quite clearly turn a taper. But in the Y-axis, if you've got, well, we do have a certain amount of nod with a workpiece, but as you move along, your tool will be, rather than being on the centre line of the workpiece, it will move up or down and will therefore go in or out relative to the centre of the workpiece, and you'll turn a taper. So what I've done is I've taken my little piece of 14mm bar stock and I've chucked it up in a collet. Everything's clean. We have an indicator just here, and what we are going to do is we are going to, at 5cm intervals, we're going to come in to a 0 on my hand wheel, just there, and we are going to find where the centre of the axis of rotation is. We're going to do that using what's known as Rolly's dad's method. This is just by averaging, basically. So we take a measure of, we're only interested in relative position, so we're going to take a measure of the lowest and highest points in the rotational movement here. So that's about -5 microns to +5 microns. The bearings need some work. That's a lot to run out, actually. That's terrible. Yes, they need retightening. And then we're going to do this at each of the stations. I have what would be the compound slide on a normal lathe, but it's the longitudinal slide moved back to its furthest extent. It will not be moving. The X slide I will pull out before moving. Pull out, wipe it on the curtains. And then move back in to 0 to take up the enormous amount of slack in the lead screw. We will move the carriage itself manually and clamp it to the bed every time. And I will mark down my results. So there we go. I'm going to get you into an overhead position and we will get cracking. So at the 0 station, we are going from -1 0.5 to plus 0.5 in X. That's 5 microns either side. Move along to the next station. Come out. Notice I'm not actually going on the ink because that's got its own thickness and that would throw our results. So at the 5 station we're going from 0 to plus 3 or plus 2.5. So 0 plus 2.5. Right, I took those readings and fed them into a spreadsheet and I got something a bit peculiar. So I took a whole load more readings. Now the first thing that was a bit peculiar was looking at Y. The Y readings, which you can see on this graph here, are pretty much a straight line. Given that my readings are kind of interpolated from a 1/100th indicator, interpreted down to nearest 5 microns really. They're pretty much a straight line, and they're a straight line drop, which indicates that there's a straight line sag of the bar. So that was a bit peculiar. So I looked at the diameters, which I've measured, which were all the same in terms of microns, and worked out what the correction to the X readings should be, again in microns, and they're all under 1 micron, so I think we can ignore that. But the X readings were all over the fucking shop. I would have expected them to be straight line one way or straight line the other way, because these are averages of the offset of the centre of rotation. But if we look at the first set of numbers here, which is offset x1, now these are taken, they're from this row here, which is the average of the low and high readings, recentered onto 0, so you recenter them onto 0, taking the first reading as 0, and then I've moved them up to 40. So that they're not overriding the others, but we're not seeing a straight line. We're seeing a plus a bit, less a bit, plus a bit, plus a bit, less a lot, less a lot. And that's very, very odd. And so I took extra readings to see whether just the bar was completely wonky, or this could be the offsets of the bed. But the bed I'd blued up and run a straight edge on, and that looked pretty square as well. So I took 5 sets of readings and averaged them, and they are averaging around the 0 mark, you know, the highest offsets we're seeing here off the average of X is, you know, minus 12 microns, plus 6. I think the bearings are playing me up. So it's time to go and clean and tighten the bearings, but the bearings on this lathe are 3 parts knackered. And then we'll probably redo this again. Whoop-de-doo. What it does show me though is that without tailstock support I'm getting a lot of sag, and that's not good. Anyway, there you go. That's where we're at today.